Hi everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about the area of composite figures. Sometimes these are called combined shapes, but composite figures is the term I've seen the most often in American math books. So a composite figure is one that is made up of different shapes, your basic sort of triangle, circle, square, rectangle, those very common shapes, and they are either being added or subtracted to each other to make these oddball shapes. So here's three examples. As you can see, this one right here starts with like a square, and we've had another little square taken out. Another way you could look at this is it is a rectangle that has had a rectangle and a square added to it. Both of those are ways to attack it. This one over here is a square that's had half a circle added to it. And here on the bottom, we have a rectangle that's had a triangle added to it. And what I just did right there is what you're going to want to do. You're going to try to identify the smaller, more standard shapes within these strange or odd composite combination shapes. So first example that we're just going to go through the whole thing is this one, and they've kind of made it a little easier. This is a sample that came from a student's book. They've made it a little easier. They've got this dotted line here to provide, the base of this triangle, but they've actually kind of like hint, hint, nudge, nudge, wink, wink. Here's the two shapes that we have. So this one is a rectangle and a triangle. So every single one of these, again, the first step is going to be to identify what shapes are in there. Sometimes you have to get a little creative. So this one's kind of straightforward, but we'll start with this one, then we'll get a little more tricky. So once you've identified the two shapes, we want to find the area of each part individually. So the first part that I'm going to do is the rectangle. So this whole area here, this rectangle, I want to find its area first. And if this is something where you find yourself when you're getting into it, that you're forgetting steps or forgetting shapes, just write them down. There's no shame in that. So this one we have one rectangle, and I have one triangle. I'm just going to use those my own little internal abbreviations. One rect and one tri. So first, my rectangle. Now the formula for area of a rectangle is length times width. So I look here, have they provided both of those? They have. 10 and 8. So, okay, my first one, my area, I'm going to zoom out a little bit, give us a little more room. Area of that rectangle, area is going to be equal to length times width. So 10 times 8, that's going to be 80, and I don't want to forget my units, inches in this case, squared. Now my triangle. Area of a triangle is area equals 1/2 base times height. Some books will say base times height over 2. It is the same thing. And I should say, if any of these area formulas for your standard shapes, your rectangles, parallelograms, squares, triangles, circles, all of those, if you're feeling a little rusty, I do have videos down below that you can refresh your memory on those. So our triangle, 1/2 base times height. And now again, I'm looking at this triangle over here. It's my other piece. And I see my little right angle indicator. So I know this is the height of my triangle, and I know the side of the triangle that it's going into is the base. Well, as you may notice, there's no number on that base. I have my height as 6, so I'm going to go ahead and write that here under my H. But I'm still looking for the base. So that's when you look at the shape overall. And here I go, well, this is a rectangle. What do I know about rectangles? I know that opposite sides of rectangles are the same. So if this side of the rectangle is 8, then its opposite side over here must also be 8 inches. And there is my base of my triangle. So it's 1/2 times the base of 8 times the height of 6. 1/2 times 8 times 6. 1/2 times 8 is 4. 4 times 6 is 24. So 24 inches squared. But I am not done yet because they want the area of the entire figure. So I cannot forget to add my pieces together. In this case, there are two pieces, 80 inches squared for the rectangle, 24 inches squared for the triangle, for a grand total of 104 inches squared. The next one I have here for you is one where something is being taken away. So look, right here, this is a quarter of a circle that has been taken away. So I'm not going to be adding at the end, but subtracting. So what am I starting out with? Well, these little tick marks, single tick marks there, mean those two sides of this shape are the same. So I'm going to go ahead and write 10 centimeters up here, just because I can. And then the double tick marks on these two sides mean those two sides are the same. So I'm going to write 20 centimeters over here on the left side. You go, okay. And I did neglect, I'm sorry, these are right angles. I'm sorry, I did neglect to include that. So, okay, so we have these right angles and I have these sides that are the same. This is a square, or it used to be a square before someone took a bite out of it. So, all right, so I have a square. And then there's this quarter of a circle that's been taken out. So, okay, I'm going to make my little note over here. I'm going to find the area of that square. I'm going to subtract a quarter of a circle. All right, so now I need to find the areas for those pieces. So our square here, we have area of a square. You'll often see it as area equals s squared, side squared. So our side here of our square is 20. So the area is going to be 20 squared, 20 times 20. Our area is 400 centimeters squared. Don't forget those units squared. Now, the quarter of a circle. Well, my area of a whole circle is pi r squared. Well, let's pretend I'm finding the area of this whole circle. What is the radius? Well, the clue here comes from these two sides, because my little imaginary circle that goes on has this as its radius, or I could say this is its radius. They're both radii. So since this whole side, this right side, if I'm looking at it, would be 20 centimeters, I know that by looking at this over here. Now, the opposite sides of a square are the same. So it would be 20 centimeters. And this is 10 centimeters, meaning this invisible line that would continue upward, which would be my radius, is also 10 centimeters. And as you see, it would have reached the same conclusion if we'd done the top, because we have 10 centimeters out of 20, leaving another 10. So the radius of our invisible circle is 10 centimeters. So now that we know our radius is 10, I'm going to say, what's the area of this whole invisible circle? It would be pi times the radius, which is 10 squared. But we do not want to forget that fourth. It is a fourth of this circle. So fourth of that full amount. So pi times 10 squared, I want to do that first. 10 squared is 100. 100 times pi would be 100 pi. And then I'm multiplying that by a fourth. You can also say dividing by 4. It's the same mathematically. So a fourth of 100 pi would be 25 pi. And again, our units, centimeters squared. So as I wrote up here at the top, my answer is going to be the area of the square minus a fourth of a circle. And I found both of those areas. So my area of the square is 400 centimeters squared. And I'm subtracting 1/4 of a circle, 25 pi. So it's all that centimeters squared. Now at this point, when you get these kind of answers and when you're doing these composite figures, you are likely to have pi in there somewhere. Anytime they put in a circle, you're going to have pi. Half circle, quarter circle, full circle, whatever they add on, it's going to add pi to that mix. If you see the phrase, leave your answer in terms of pi, or give your answer in terms of pi, then this right here is your final answer. If it says to give it as a decimal, like a rounded decimal, then use your calculator to multiply 25 times 3.14, or the pi button on your calculator, and then subtract that from 400 to get your final rounded answer. So for all these composite figures, the key first step is going to be to identify what shapes are involved. 2, figure out your game plan of whether you're going to be adding shapes or subtracting, or even a combination of both, depending on the shape. And then step by step, find the area of each of those pieces and add or subtract accordingly. And do not forget your units squared.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.